Okay, so today we're going to go over partial fractions. Okay, so let's say, for example, what if we wanted to try and integrate the integral of 1 over x squared minus 5x plus 6 with respect to x. Okay, so you couldn't use u substitution, you couldn't use anything that we've learned so far. Okay, so what if you could figure out that 1 x squared minus 5x plus 6 is equal to 1 over x minus 3 minus 1 over x minus 2. Then you could just have the integral of those two terms. Okay, so the integral of 1 over x squared minus 5x plus 6 with respect to x could just equal the integral of 1 over x minus 3 minus 1 over x minus 2 with respect to x. And each one of those just being u prime over u just be the natural log of x minus 3 minus the natural log of x minus 2 plus c. Okay, which is a whole lot easier. Okay, so today we're going to go over how to basically turn this into this. All right, so bless you. Oh, anyone's still writing? All right, leave that up for a few more seconds. Yes.
So why wouldn't it be plus 1 over x minus 2? Because when you put in the subtraction, that would be negative x plus 2, correct?
Which part which step are you on? This one?
Below that.
This
the
one?
Integral of 1 over, yeah, what? When you distribute that negative, what does that make that negative x minus 2 when you try to combine them?
That would be, well, let me double check. Unless I wrote down the problem wrong. Let me make sure.
I'm probably wrong. I just don't know.
1.
Because if you try to cross multiply.
Yeah, because actually, if you look at it this way, you have, where's the question? There it is. 1 over x minus 3 minus 1 over x minus 2. Make this one x minus 2 over x minus 2 and x minus 3 over x minus 3.
Okay.
So that gives you x minus 2. That becomes plus, well, no, that becomes minus for that one. So you have minus x plus 3 over x minus 2, x plus 3.
Okay.
All right, does that make sense?
Yes.
No, okay. Oh, I'll add this to the notes. right. Okay, so let's say for the first method, dividing improper fractions. Okay, which pretty much means that your degree of the numerator is higher than your degree of the denominator. Okay, so for example, what if we wanted to evaluate the integral of negative 3x squared plus 12x minus 12 all over x minus 1. Okay, so x squared larger than x. So whenever you have an improper fraction, probably the easiest way to do it would just be to divide negative 3x squared plus 12x minus 12, divide that by x minus 1. Now the thing is, as long as your denominator doesn't have a coefficient in front of the x, you can use synthetic division, which is a whole lot easier. Okay, so quick reminder of synthetic division if it's been a while. So let's, if you have, oh, actually I'll finish this up on the next page. Okay, so if you have a, let's say, rational expression, and I'll say ax cubed plus bx squared plus cx plus d divided by x minus k, then you can use synthetic division. Which, if you remember, you just get your k, kind of sit it on the outside, kind of use an upside down division bracket, and you put all of your coefficients and line them up right across the top. So you have A, B, C, and D. Okay. Now the first one, you're just going to bring that right down. And as soon as you bring it down, you multiply these two. And you put your answer right there. Okay. And then you add these two together. Okay. So let's say you add these two together and you get some number f. Okay. So now you multiply k and f. And you add those two together. Let's say you add c plus whatever k times f happens to be, and you get some number g.
Does that say x minus k or x plus k for the rational expression above?
Which?
Looking at the fraction.
Your rational expression example.
Oh, this one? X minus.
No, down.
Oh, down.
Down. The actual generalized thing.
Oh, this one?
Yeah.
Oh,
Is that
minus.
minus or plus?
Minus.
Okay.
Yep. Okay, so now you multiply k and g, and you add those together. And whatever's left is going to be your remainder. Okay, now the good thing about this is it doesn't take up a whole lot of room. So we have plenty of room to actually finish this one. Okay, so for x minus 1, and let me rewrite it real quick, plus 12x minus 12 over x minus 1, for this one, your k is going to equal 1. Okay, so you put your 1 there. And you write all your coefficients, which is -3, 12, and -12. Okay, so your first one, you just bring that right down. So -3. 1 times -3 is -3. You add those together. Okay, so you end up with 9. 1 times 9 is 9. So you add those together, which is -3. So that's your remainder. Okay, so that means here you had 3x squared. So this was an x squared. This was 12x. And this was just a constant. So that means once you divide, your x squared now becomes an x, and your x becomes a constant, and your remainder just stays your remainder. Okay? So we can actually say that, where's that? -3 x squared plus 12x minus 12 over x minus 1 is actually equal to -3x plus 9 plus -3 over x plus 1. X minus 1. Don't know why I put x plus 1. I know why. I was just seeing if you were paying attention. You were. All right. So really, if you're going to integrate those, you can integrate this right here because it's a whole lot easier. 3x, so that's -3 over 2x squared, plus 9x, bless you. That -3 we can, plus 9x. That -3 we can bring that right to the front. And that will give us 1 over x minus 1, which is just natural log of x minus 1, plus c. Okay, so really we just worked it all out right down there. All right, so any questions on that one? Okay. Bring that down a little bit. All right, so let's say, for example, want to integrate -9x squared plus 48x minus 22 divided by x minus 5 with respect to x. Okay. So we can see there we have an improper fraction. Okay, which means we just go ahead and divide. Okay, so for this one, we know your k is equal to 5. Okay, you have 5, and we put all of our coefficients right along next to it. So you have -9, 48, and -22. Okay, so you go ahead and bring down our first one. 5 times -9 is -45. And we go ahead and add them together and end up with 3. 5 times 3 is 15. Add them together, end up with negative 7. And that's your remainder. Okay, so we had x squared up here. So negative 9x squared plus 48x. And negative 22 is your constant. Okay, so each one of those exponents are going to drop 1. So instead of x squared, this will become x. This will become your constant. And that's your remainder. Okay, so we know that the integral of negative 9x squared plus 48x minus 22, all over x minus 5 with respect to x, is just going to equal negative 9x plus 3 plus negative 7 over x minus 5. Which as soon as you integrate all of them individually, you get negative 9 over 2 x squared plus 3x. Bring that minus 7 down to the front. Becomes a natural log of the absolute value of x minus 5 plus c. Okay, so any questions on that one? All right, leave that up for a few more seconds. Excuse me. All right. Okay, so what if we have negative 8x squared minus 65x minus 69 divided by x plus 7 with respect to x? Okay, so I'll give you a few minutes to start on this one.
Is that a minus, isn't
Numerator or denominator?
it? Numerator.
Yep, all those are minus. Either minus or negative. Let's see. Is it better with the light or without? Without? With?
Yeah, without.
Without, okay.
Does it matter if we use synthetic division?
Oh no, if you want to use regular division, you could. This might take a little longer, but same result. swear I get caught at least twice a week by that train. Okay, I'm going to point out the most common mistake with this problem. Remember, the denominator must be in x minus k form. So that means x plus 7 has to equal x minus negative 7. Okay, so for this one, your k would have to equal negative 7. Right, so that means we have negative 7. List all of your coefficients. Negative 8, negative 65, and negative 69. Okay, the first one, just bring it on down. Negative 8. Negative 7 times negative 8 is positive 56. And we add those together. We end up with negative 9. Multiply those two, you get 63. Add those together, end up with negative 6 as your remainder. Okay, so we know if this is x squared, this is x, this is just your constant. The exponent drops 1, so this becomes x. This becomes your constant, and that just stays your remainder. Okay, so we end up with integral of negative 8x squared minus 65x minus 69 over x plus 7 just equals the integral of negative 8x minus 9 plus negative 6 over x plus 7. Or you can make it minus 6 times 1 over x plus 7. Wouldn't matter. With respect to x. Which, once you integrate each one individually, x squared over 2 gives you negative 4 x squared minus 9x minus 6 times natural log of x plus 7 plus c. All right, so any questions on that one? Okay, so that's just if you have an improper fraction. That's one of the quicker ones. Oops, one's still writing. Okay, looks like everyone's done. Okay, the next one is if you have a non-repeating, distinct linear factor in the denominator. Bless you. Okay. So in other words, let's say if you have some function f of x equal p of x over q of x, where you can actually factor q of x to equal some a1x plus b1 times, actually I should put that on the next one because it's going to eventually run out of space. So let's say q of x is equal to a1 of x plus b1 times a2 of x plus b2 times a3 of x plus b3, and it keeps on going until eventually it ends. So a sub n of x plus b sub n. Okay. So in other words, each one of those are completely different. Okay. So that means we can rewrite our p of x over q of x to equal a1 x plus b1 plus a2 of x plus b of 2 plus, and you just keep on going until eventually you get to the end. A sub n over a sub n of x plus b sub n. Now in reality, we usually use a, b, c, d for that one, but because we have some unlimited, not unlimited, but a limited number of alphabet letters, just easy to use a sub 1, a sub 2, and so on.
Is it important that the numerator is capitalized?
Usually it's capitalized just to kind of separate it. Yeah. Oop, move that up for a little bit. Okay, so let's say if we have for our first. Oh,
Could you put that back
Oh.
on just for a split second?
oh, not a problem.
You're probably gonna wanna restart your recording before you,
Oh yeah.
start the next example.
Okay, I did it.
All right. Anyone else still writing?